again, spring pressure through the cam, through the sprockets, into the chain, being held onto by the timing guides, and then driven by the crankshaft snout and the crank gear. So because of the extra pressure in the valve train, we added the extra components for the timing system. Could it have lasted on the stock components? Probably, maybe, I don't know. But I'm not here to find out with I don't know. I want to actually play with this car and do some damage with it, you know? So, we're gonna do a Cometic head gasket on the top of the motor to mount the heads. We've got our ARP studs. So I did do the studs. And the reason I did the studs is because the last motor I put together, I used the Felpro bolts, which I had one around here somewhere. Hold on, there it is. Okay, there we go. So I was using these bolts. These are just regular like Felpro $40 head bolts. They did great. These things kicked butt. Tightened down on the block through the head, blah, blah, blah. These bolts are a torque to yield design, and they made it to 600 horsepower. When it started going over 600 horsepower on the dyno, no matter what, well, okay. Reset. These went to 600 horsepower. The reason being is because once I got to 600 horsepower, I had so much cylinder pressure that it was stretching the bolt. It was stretching it off the block. So what was actually happening is the head was lifting off the block, and I was losing pressure from the inside of the engine, and it was pushing itself into the cooling system, and it was blowing coolant out of the reservoir at the front of the car. So when that starts to happen, nothing else happened on the motor. I would stop the pull and, well, I'd do a pull, blow some coolant out, do a full pull, wouldn't notice really anything, stop doing the pull, the car would run completely fine, because every time it stretched it out and it would blow pressure into the cooling system, when I came out of the throttle, the thing tightened itself back down and it sealed just fine. So it was only when it was like really, really, really high cylinder pressures it was pressing out into the cooling system. So that was the failure that we started to see once we got past 600 horsepower with that motor on these $40 bolts. So we now upgrade to our ARP studs, and that's gonna clamp down the heads much, much better. And then also we're gonna use a Cometic head gasket, and that's gonna help hold these heads in place really, really well, and seal it for a little bit higher horsepower. The important thing when you're using head studs, just like I mentioned with the main studs, if you put a higher pressure bolt in, there's a thing called clamping pressure. And clamping pressure is how much pressure is on the component when you tighten down the bolt. Imagine a bolt like a big strap, like a cloth strap, right? Right? So the bolt's made out of different material, so the cloth strap's a different material. On a torque to yield bolt, basically what's happening is you're tightening the bolt down to where it's straight. Like the cloth strap, hits its tight point, right? And then you crank it down and stretch it. And then that's when you're left with that tight feel. So it's like when you use a ratchet strap and you ratchet it down and you get to where it's tight, and then you crank it down and you pull all the play out of the fibers, right? So that's what you're doing with this bolt, is you're clamping it down and then you're tightening it so it actually starts to gain a plastic property and stretch itself to the point that it like stretches the material, and it creates like a tight spring effect to it, so it can't stretch under load, right? And it was starting to stretch under load, but you're getting rid of most of that by tightening these bolts down and stretching them. The ARP bolt is a much stronger material, so you don't actually stretch it, because the way the grain and the way the metal has been treated is already very straight and strong. You're not having to stretch it into place, basically. So the difference when you add something like that is now you're changing the clamping pressure to the component. So what happens when you do that? Well, metal moves and flexes and gets hot and expands and contracts and blah, blah, blah. When you tighten these down with the head on, it actually flexes the hole out of round. So if you switch from these bolts to these, it is gonna pull the cylinder out of round. Enough to make a big problem? Probably not, but could potentially cause the piston to have an issue or something like that over time, and you could kill the longevity of the engine. So the way to combat that is, like I said, you have to have all these ideas before you go to the machine shop. And basically what you do is you take it to the machine shop with your entire build that you're gonna do. So I brought these to the machine shop, and they put a big torque plate on top of it, which mimics the head being installed. And then with the torque plate on, they tighten these down, and the torque plate, and with these bolts tightened down, flex the cylinder to where it's gonna be when the head is installed. And then once that's on there, they then cut the cylinder and they hone it and set it up. And the other cool part is when they have all the other pistons in there, they actually measure the piston that's gonna go in this hole, cut it for that piston, and then label the piston for that hole. So this piston, this hole was cut specifically for this piston, which you just can't beat it. So now, like I said in another video where we talked about the components of a bottom end, everything's married to itself. And this engine is now, all these components are designed for this exact thing. I've got a couple other little things that I'm using, like this trigger wheel. So Ford has a couple different trigger wheels. This is a but this is a cast wheel. The problem I had on the last build with the cast wheel is when I tightened it down and got a lot of RPM out of it, it actually snapped in the center. So the center of it, not disappeared, but just like literally a crack went around it, and it was like you could spin it like a dial phone. That's what shut down the Mystic originally, was this component right here. When the Mystic went on the trailer for the last time, it was like dead engine basically. This is what broke. It literally just snapped a ring and it was able to spin, and I lost RPM signal. I could have just replaced this and put the engine back in the car and ran it. Like, it would have been fine. But again, I like my life to be hard, so I decided to start rebuilding everything again. This is the other one. This is a stamped steel version of the trigger wheel. This one is okay, but the problem with this one the problem with this one is when you hit a lot of RPM, it'll actually flex because of the thinness of the metal, and it gets kind of wavy, kind of like a CD-ROM. If you spin it too fast, it starts to get a wave to it. That will happen on this, and then your crank signal starts to deviate a little bit, which isn't great when you're talking about a race engine, blah, blah, blah. So this one, great part. It's a billet wheel, so it can be compressed. It's not gonna snap like the other one, and also it'll hold itself nice and straight for the crank signal. So I'm gonna get a nice strong crank signal out of it. And quite frankly, everything the engine runs on in the tune is based off of having a quality crank signal. So that's a really important component for us. All right, that's pretty much the engine. I got the other head right there. Everything should be good to go. Those are extra parts and stuff. So I'm gonna start getting this thing underway, and hopefully next time you see it, we have a Longblock sitting here, and we'll be ready to go. All right, ladies and gentlemen, be good, be safe, and love your people.